Now we will look at the indefinite integrals of some mathematical function first and its basics integrations rule. First one, the integrations for a constant function k will return the result kx plus c, where c is a constant. So for example, the integrations of pi will return pi x plus c. And integrations dx, this one is actually the integrations of 1. So then the result is x plus c. Next, to integrate x to the power of n, the answer is basically we will take x to the power of n plus 1, we add 1 to the power and divide by the new power. So for example, to integrate x to the power of 2, we're going to get x to the power of 3, which is 2 plus 1, and divide by 3 plus c. Integrations for x to the power of negative 2, let's say, then should equal to x to the negative 2 plus 1, which is negative 1 divided by negative 1. So the answer is actually negative x to the negative 1, or negative 1 over x plus c. The example, we can look at x to the power of half. Then we should have x to the power of half plus 1, which is 3 over 2, and divide by 3 over 2. So which is actually equal to 2 over 3 times x to the power of 3 over 2 plus c. So these rules is basically can be applied to all n except n not equal to negative 1. That is because if n equal to negative 1, so negative 1 plus 1 here, we're going to get something divided by 0. So this is undefined. And hence, when n equal to negative 1, so this is the case, 1 over x, which is x to the power of negative 1, where n equal to negative 1. Integrate 1 over x actually will return ln x plus c if x larger than 0, and ln negative x plus c if x less than 0. And usually, we're going to write it in this form, which is ln absolute x plus c. In the next examples, to integrate x to the power of half, so we should get x to the power of half plus 1 and divide by the new power, which is half plus 1 plus c. So we have x to the power of 3 over 2 and divide by 3 over 2 plus c, or in other words is 2 over 3 times x to the power of 3 over 2 plus c. Now the integrations for trigonometries and hyperbolic functions. To integrate sine x, we get negative cos x. Integrate cos x, we have sine x. Integrate tangent x, we have negative ln cos x. Integrate sin x, we have cos x. Integrate cos x, we have sin x. And integrate tan x, we have ln cos x. Since integration is a reverse operations of differentiations, you may actually refer to the sections of differentiations to get the basic integrals for more mathematical functions. Now we will look at the basics rule for the integrations. The first one, the constant multipliers rule. If a constant, let's say alpha, is multiplied to a differentiable function f of x, then to integrate alpha f of x is actually we can take the alpha out and multiply with the integrations of f of x. So for example, the integrations for f 3x squared is actually equal to 3 times integrate x squared with respect to x. So we have 3 times x cubed over 3 plus c, which is then equal to x cubed plus c. The next case, to integrate 4 cos x, we can take the 4 out. So 4 times integrals for cos x. To integrate cos x, we're going to get sin x. So the answer is 4 sin x plus c. Next, we will look at the sum and the difference rules. Let's say we have two functions, f of x and g of x, and both of these are differentiable functions. Then to integrate f of x plus g of x or f of x minus g of x, we can do them separately. That is, I integrate f of x and integrate g of x separately. Then I add them back or I subtract them back. Okay, for this problem. So let's say this is the examples that we have. Now to solve this problem, I can integrate x cubed and then x and then 2 separately. So integrate x cubed, I'm going to get x cubed plus over 3 plus c and x squared over 2 plus c2 and then 2x plus c3. So this c1, c2, c3 are actually constant. So I can write it as x cubed over 3 plus x squared over 2 plus 2x plus c, where this c is actually c1 plus c2 plus c3. Next example, to integrate e to the x minus sin x. So this one, then I can do integrate e to the x and minus integrate sin x dx. So the first part, integrate ex, I have e to the x, and integrate sin x, I have cos x. And then finally plus a c. This c actually comes from the constant here. There should be a constant c1 and another constant c2 here. And finally, I write them as a constant of c.